Alright, today we're going to be talking about quadratic word problems. The first one that we're going to be dealing with is talking about a toy rocket. It's being launched vertically upward from ground level with an initial velocity of 128 feet per second. Then its height h after t seconds is given by the equation h of t equals negative 16t squared plus 128t. So there's a number of questions that they're asking us for this. And so on this first one, we're just trying to learn how to use Desmos to help us the most. So we're going to go ahead and type this equation into Desmos. The one thing we have to keep in mind, though, we can only use x's and y's. So anytime we see h of t, that's the same thing as y equals. And then t itself is our input variable. And so that means that we are going to use x for that. So we're going to type all of this in. And we can see part of the graph here, but we need to be able to see all of it to figure out all the answers to this question. So if you tap on the little wrench there, we're going to leave our x-axis the same because we can see both sides of this parabola, and it does make sense that it should be facing down because of that negative there. Now what we can't see is the top of this parabola, so we're going to keep it from negative 10 to, let's go positive 300 for this. And now we're able to see everything. You could technically even move this further over this direction if you want. Now, the first part here says to sketch and label a graph that represents the situation. So what we need to do is draw ourselves just a graph here. And remember, for this situation, we only need the first quadrant because if we're talking about time, we can't have negative time. And if we're talking about height of something, it's going to be above the ground. So we don't need anything negative here. Now, this axis here is the height, and that is being measured in feet. And this axis here is going to be time measured in seconds. We're just drawing a very basic picture of this, so this does go up pretty quick and come back down the other direction. I know that this isn't totally based on scale, considering this up here, is somewhere closer to 250, and this is 10, or somewhere around 10 here. So we're just going to put that 10 there, and 5 here, and then we know that it goes, 100 here, 200 here, and then 300 would be somewhere further up here, based on our graph. Okay? So that's just a very general sketch and label of what the different axes stand for. Now, depending on what they're asking in the question is going to depend on where we're looking for this graph. Part B says, after how many seconds will the rocket be 112 feet above the ground? Okay, where's the ground in this situation? The ground is going to be here, your x-axis, and then here is going to be our height. So it says after how many seconds, after how much time this way, are we going to be 112 feet above the ground? So we know we're going to be somewhere right on this area, or if I look over here, it looks like it's going to be pretty close to 1 second, but we want to figure out the actual value of it. So if you click on the graph itself, and it's highlighted over here, click on the little gear shift at the top, and then click on the table. Now, this gives us a table, and it's already going to pre-populate -2, -1, 0, 1, 2 for us. And we got to see what these values are. So the x coordinate here in the left is going to be the time, okay, or the seconds that we need. And the y coordinate over here is going to be the height, how high up that rocket is after that number of seconds. So I just scrolled a little bit here and I noticed that at 1 second, the rocket is 112 feet, which is exactly what I want. So we're going to say 1 second. And you can abbreviate that 1 second if you want. The next part says, how long will it take for the rocket to return to the ground? So again, let's take a look at our graph where the rocket's going up, it's going to come back down, and it's hitting the ground right here. Now, it looks like it's 8 seconds, but we're not exactly sure. So in our chart, we can, if I can get this to go. In our chart, if we go down here, we can just keep hitting enter and it's going to keep producing more points. We want to know where it's hitting the ground. So the ground is 0 feet. That means it is truly 8 seconds. And that's where you can click off of that and see that as well. So it will take 8 seconds for it to reach the ground again. Okay, so there's the ground right there for us. Now it says, how long will it take the rocket to reach its maximum height? Okay, we're talking again about this rocket. It's being launched, it's going up, hitting this highest point, and then coming back down to hit the ground. Maximum height is talking about the vertex. So if you click on that vertex, or if you look in your chart here for where you're starting to see that pattern of things going, and the light is not doing so well for us, that vertex is 256. Height, that's our y coordinate of our vertex. And so that means it will take, it says how long will it take us? So that's going to be our 4 seconds. That's going to be the x coordinate, the time, how long it takes. The next part down here, so let me get this situated here. It says, what is the maximum height? That's where we're going to be looking at that y coordinate of the vertex, okay? Maximum height is talking about the y coordinate, and so then that is going to be 256 feet. Now, the last question that this asks us is, how high will the rocket be after 2 seconds? Okay, seconds is counting in time, so that means I want the x coordinate of 2 seconds. Now, we can look at this and kind of estimate. I know our sketch is not great, so if we're looking over here, after 2 seconds, we're approximating there. We can look over at our chart as well, and we see that 192 is the coordinates of that point. So after 2 seconds, the rocket would be 192 feet above the ground. A lot of these questions are going to focus on maximum height, which would be the vertex, or how long it takes to get the maximum height, which again is the vertex, and then when it reaches the ground, and again, that's looking at the zeros of this and where it would be. All right, let's take a look at another one here. The second example that we have here is ones for you to try. So if you feel as though you want to try this one, pause the video and try this one on your own, you can feel free to do that. Let's take a look here at this one. It says a grasshopper jumps off a tree stump. The height in feet of the grasshopper above the ground after t seconds is modeled by the function shown. So that's the function we're going to type into Desmos. So we have y equals negative x squared. Remember, we cannot use t's or h's here. Plus 4/3 x plus 1/4. Ooh. See now what I did there? I did not make sure that after I was done with my 4/3 I put x in there. So we got to be careful with that. Alright, so you're going to notice we can't see anything. We're talking about a grasshopper. The last question was talking about a rocket. So I'm going to hit that home button, and it's going to allow me to see a little bit more of that graph. Now, instead of hitting that button there, you can also zoom in yourself and look at this. Okay. So here it's asking us, after how many seconds will the grasshopper land on the ground? So where is the ground again? The ground is going to be our x-axis here. That means I want that point right there. If it's starting out on a tree stump, it's not going to be on the ground on the left-hand side of this. It's going to jump up and then land on the ground. With this coordinate, seconds is going to be our time along the x-axis. So it is taking this grasshopper 1.5 seconds to land on the ground. All right, one last question here for you to try. So again, if you want to pause the video, try this one on your own and then check in. That would be great. This says, what is the maximum height of a rocket fired straight up if the height in feet is described as h equals negative 16t squared plus 64t plus 1. where t is the time in seconds. All right, so I'm going to try and get the glare to not be so bad there. All right, we're going to hit the home button again to get our normal zoom. And we're going to type in our equation. Now, technically you don't need to type in the y equals part, so if you just went straight to the negative 16x squared part, you would be okay. All right, so again, we can't see the top of this, so I'm going to, instead of zooming out, if we zoom out a bunch, you're still not going to be able to see everything that you need. It's going to be really, really narrow. So let's go ahead and change our y maximum to be, let's try 100 and see if that works. Okay, that's perfect. So we can see enough. That means that you could have used something different than 100, but as long as you can see everything that's happening. Because this is talking about what's the maximum height. And if we're talking about height, that means we want this vertex right there. And the nice thing about Desmos is it will tell you the zeros, and it will tell you the vertex of any quadratic that you type in there. What is the maximum height? If our coordinates of our vertex are 265, height is going to be our y coordinate here. So we're going to answer 65 feet. That's it.